The tests you have described are rooted in actual chemical phenomena and are frequently used in viral social media experiments and by home soap makers. However, the conclusions often drawn from these demonstrations, specifically the idea that real soap is inherently healthier while fake synthetic detergent, SYNDET, bars are harmful, fundamentally misunderstand both the chemistry of cleansing and human dermatology. To understand why a bar of soap scorches under a flame or reacts poorly to hard water, we must explore the molecular mechanics of saponification, the role of synthetic surfactants, and how varying pH levels interact with the biological barrier of your skin. The chemistry of real soap versus SYNDET bars. The distinction between a true soap and a SYNDET bar comes down to the chemical process used to create the cleansing agent. True soap is the result of an ancient chemical reaction called saponification. When you combine natural triglycerides, fats or oils such as olive oil, coconut oil, or tallow with a strong alkali like sodium hydroxide for solid bars or potassium hydroxide for liquid soaps, the molecular bonds break and reform. The reaction looks like this.
30 seconds.
$text triglyceride /oil. A +3 text NaOH right arrow text glycerol +3 text RCOO text Na text soap $. The resulting molecule has a hydrophobic, water-repelling, fat-binding tail and a hydrophilic, water-attracting head, allowing it to trap oil and dirt and wash it away. However, true soap is inherently alkaline, typically resting at a pH between 9.0 and 10.0. SYNDET bars, often labeled pejoratively online as fake soap, are composed of synthetic detergents. These surfactants, like sodium cocoyl isethionate, are often derived from natural oils or petroleum but are synthesized in a lab to create specific cleansing behaviors. The critical difference is that SYNDET bars can be pH adjusted to match the skin's natural acid mantle. The human skin barrier operates at a slightly acidic pH of roughly 5.0 to 5.5. Washing with highly alkaline true soap strips this protective lipid layer, increasing transepidermal water loss and causing dryness. SYNDET bars, by contrast, preserve the acid mantle. This is why dermatologists universally recommend SYNDET bars, like Dove or Cetaphil, over traditional lye soaps for individuals suffering from eczema, rosacea, or chronic dry skin. Analyzing the flame melt test. Viral videos often show a traditional soap bar charring under a blowtorch, while a commercial SYNDET bar melts into the puddle. This is visually striking, but it merely demonstrates the varying thermal dynamics of different structural ingredients, not their safety or quality. True soap is essentially an organic salt, the sodium salt of a fatty acid. Salts generally do not have low melting points. Their molecular structures are highly crystalline and stable. When exposed to extreme temperatures, above 200 degrees Celsius, the carbon-carbon bonds within the fatty acid chains begin to break down before the entire matrix can transition into a liquid phase. The soap decomposes, scorches, and chars, releasing carbon dioxide and water vapor, which causes the bubbling effect. SYNDET bars behave entirely differently under heat due to their physical composition. The active synthetic surfactants in a SYNDET bar are too soft to form a hard, solid shape on their own. Therefore, chemists must add binders, structural waxes, and fatty acids, like stearic acid or cetyl alcohol, to hold the bar together. These structural ingredients are designed to be solid at room temperature, but possess relatively low melting points, often between 50 degrees Celsius and 75 degrees Celsius. When hit with an open flame, these binders rapidly cross their melting threshold and liquefy, causing the SYNDET bar to wick, drip, and melt exactly